Start with edit. So this is manual layout. Close this file, new, browse for Tana database file, go to Tana RDA, Tana tools, edit and LVS, tech folder. So under this you have generic. Select the generic file .tdb, open, then click OK. Setup, design, grid, major display grid. Change the major display grid as 0.25 and minor display grid as 0.125. Mouse grid, smooth. Okay. Select the active layer first and draw the selection box. So if you press plus here, it will zoom in. Minus means zoom out. Plus key, it will zoom in. As minus key, it will zoom out. You can see the grids. So arrow marks indicate selection mode, whereas boxes indicates the drawing boxes, the layers which you can draw in the form. So this you have done active layer. Press Ctrl E and select in edit objects. Always you have to select show box coordinates as bottom, left corner and dimensions. Now change the height for active layer as 2.5. Click OK. Now if you select the layer and placing the cursor on the edge, try to drag the active layer after selecting it. Try to drag it in a minimum way is enough. Next, poly layer. Access the drawing boxes, select the drawing boxes. Now draw the poly layer. Press Ctrl E. Edit objects window. In edit objects window, you have to change its width. Select always bottom left corner. Change its width 0.25. Change its width to 0.25. Then click OK. Now next, metal 1 layer. So this is the minimum width if you consider for metal is 0.48 and 0.48 in terms of lambda rules. Select it and drag it and place it in the center. Now based on that, try to minimize the active layer. Copy the metal layer and paste it on the other side. Next, go for active contact. Select the drawing boxes. Now press Ctrl E. and click OK, and perform DRC to check whether error is there. So there is one error, that is the distance between active contact and metal is less. And select the active layer, go to selection mode, select the active layer. Now these two layers can be neglected because select layer is not being added and metal 1 has been used. Now copy the active layer and paste it on the other metal layer. Perform DRC to check. So these two errors can be neglected because the MOSFET no select layers have been added. Copy the whole, select all, copy it, then paste it below to it. So this will be adding as base for diffusions as well as polymaterial for both PMOS and NMOS. Copy this layer, select this layer using active layer metal as well as active contact, copy it, then paste it on the side wedge, place it on the side wedge, then using cut selected objects across vertical axis, using this place it in the center and click it. Once you click it, the layers will be divided vertically. Now select it, half of it, and place separate it. Select this particular object, place it on the next to one MOSFET diffusion, and select the other layer and place it on the other side. Place it below. Now to try to minimize the layer, make it as even, uniform. Now place the select layers. First select P select layer, drawing boxes, then draw the P select layer for PMOS, and P select layer for ground. Next N select layer for VDD. After placing for NMOS, N select layer, DRC. So metal 1 density error can be neglected because metal 1 has been used there. Next, place N well on PMOS. Perform DRC to check any error is there. Metal 1 density can be neglected. Next, select the metal layer and try to connect VDD with source of PMOS, and PMOS's drain is connected with NMOS's drain, and NMOS's source is connected to ground. Switch to next, minimize the layers, So why it is being considered minimizing layers is low power, low area. VLSI means low area, so this represents low area. If you are minimizing it, it considered according to design rule check, it is being called low power. The next, port naming. So according to the layers, you have to name the ports and positions. Select metal 1 and name it as VDD. Increase the size if you want to. Next, click OK. Next, poly. Input as poly. So click on poly material. Select poly material. 36. Increase the size. Next, output. Select metal 1 layer. Then port name. Change the port name. Y. Increase the size to 0.36. Click OK. Next, last one is ground. Select metal 1 layer. Change the name ground. Give it ground. Change the size. Then click OK. Now run DRC. So if you see here below, you can find on the left hand side corner, you can find the dimensions of it. For each and every layer you have specific dimensions, as well as you can see the port names being selected. When you are selecting the port names, it's giving you along with the layers and as the type of it, and active layers with active contact with dimensions, and active layers metal layer with dimensions. And select you have, and well you have with dimensions on the left corner. Save this design in the particular folder NT4. So all the designs should be saved in the same folder. So give the initials of experiment so that you can remember. Save it. So next, setup extract. Select extract standard rule set, then edit commands, pencil symbol. You have to browse for library file .ext, generic.ext. So Tanner tool, Tanner EDA,Ledit and LVS, you have to go for generic folder. Change the name of the spice file. Save it in the particular location folder. Save it. Output, delete this line. Click OK. Extract spice file. The spice file is extracted. Spice file is being constructed. Next is so we have generated the spice file. Now this indicates the spice software edit and its location where you have saved it, and time and date being generated. Drain connection as well as gate, source and substrate connections, you have it. So source and substrate connections. Press the cursor, press enter. Now insert the commands through insert command. Analysis transient 10 nanoseconds maximum time. Simulation time 100 nanoseconds. Insert command. DC transfer sweep, sweep 1, select. linear sweep, source parameter V1, start 0, stop 5, point 1, 0.01, okay, increment you select it as 0.1, insert command. Next, library file, include library file, browse, Tanner EDA, Tanner tools, libraries, models, generic 0 to 5, click open, type TT, insert command, voltage source, pulse, V1, A input, ground, initial voltage 0, peak voltage 5 volts, rise time 1 nano, fall time 1 nano, pulse width 10 nano, 20 nanoseconds pulse period, insert command. Next, constant V2, positive terminal VDD, negative terminal ground, DC value 5 volts, insert command. DC results. Next, output DC results, type the node name output, add to the graph, insert command. Next, transient results, give input node name, add to the graph. Next, Y, add to the graph. Next, insert command, close it, dot op, type dot op, save it, press F5 or run simulation. Wait for the result. Being considered as a small thing, but turn behind them. Now you have the result. First one, above one is DC result, DC characteristic of inverter, and below one is output as well as input. Pink color shows the input and as output. Select all, then press the home button. You are going to get brief about inputs as well as output voltages. Now markers will provide you detail in terms of x-axis as well as y-axis from the initial 0 point in terms of time, nanoseconds. Now save the file in the location, the same folder,